All right, let's take a look at synthetic division. Okay, this is just another simpler way to divide two polynomials. It takes a little bit less time than long division. We can only use this for certain problems, though. Okay, we can only use synthetic division if the divisor is in the form x minus a, right? X plus or minus a, but we think about it as x minus a. So here, in this first example, our divisor is in this form. Right? So yesterday, we would have set this problem up like this. Right? We would have used long division to set this up like this, and then the process was figure out what we have to multiply this term by to get this term, put that number up here, so that would be 2x, then multiply this by both terms. So we would get something like this, subtract, right? These would cancel, we get 7x, then repeat, so, oops, bring the 6 down, and now repeat, so x times 7, then multiply 7 times everything over here, subtract, and we would get 27, so 27 is my remainder, so we wrote that as plus 27 over x minus 3. So today, let's do this same problem using synthetic division. Okay, the process for synthetic division is to first write out the coefficients of our dividend, okay, the polynomial that we are going to divide into. So my coefficients would be 2, 1, and 6. So list those all out. And now I'm going to put up here in a little box the solution to this factor. Right? So we're saying x minus 3 equals 0. Then to solve that, we would add 3 to both sides and get x equals 3. Right? So we're just thinking about the solution to this factor is the number that goes up here in our box. Now, the process, we bring this first number straight down. Now I take this number and multiply by whatever number I have up here. So 2 times 3 is 6. Now I add these two numbers together. So 1 plus 6 is 7. And do it again. 7 times 3 is 21. Add 6 plus 7. We get 27. All right? Now, what we have just come up with down here are the coefficients to our answer. We started with a second degree polynomial, so my answer will be 1 degree less. So this was a square, this will be 2x to the first. So my answer is 2x to the first plus 7, and then 27 is my remainder. Whatever this last number is my remainder. So just like before, we write our remainder like this. So we get the same answer that we did using long division. All right. Let's take a look at another example here. So on this one, my divisor up here would just be 2, right? The solution to the factor of x minus 2. And then I list out my coefficients of my dividend. So 1, negative 2, 3, negative 6. So bring this first number down, multiply, add, multiply, add, multiply, add. So in this case, we get a 0 remainder. So my answer, since I started with a cubic, right, this was 1x cubed, this coefficient will be 1 degree less. So this will be 1x squared plus 0x plus 3, and then no remainder. So my solution is just x squared plus 3. And remember, we said another way of thinking about this is, well, this polynomial x cubed minus 2x squared plus 3x minus 6 is equal to x minus 2 times x squared plus 3. All right. Now, I want you guys to try this one, but I do want to point one thing out before you start. All right, so we know that the solution to x plus 1 will be -1, so that's what goes in my box. Now I want to list out my coefficients. So 2, 0. Okay, now just like we did with long division, we have to put a placeholder for every missing power as we start going down. So 2, then 0x cubed, then -3x squared, 5x, and 17. Okay, so you guys take a minute and try this one. All right, so bring the 2 straight down, multiply 2 times -1, add, multiply, add, multiply, add, multiply, and add. So since I started with a 4th degree polynomial, this will be the coefficient on my 3rd degree. So my answer is going to be 2x cubed minus 2x squared minus x plus 6, and then 11 is my remainder, so that will go over x plus 1. All right. Now, if the remainder is 0, okay, just like we got for number 2, okay, that was our only example, or for B, I guess, where our remainder was 0. What that means is the divisor is a solution or a root. So if we look at example B here, x minus 2 divides evenly into this polynomial. That means that this graph, if I were to graph x cubed minus 2x squared plus 3x minus 6, my graph would cross the x-axis at 2. Okay, it is a 0, it's a root, it's a solution. Right? So we're going to use that idea a lot more in the next section. Right? For now, okay, we're going to take a look at actually another way to figure out if we have a solution, if a factor is a solution. So a remainder theorem says if a polynomial is divided by x minus a and then the remainder is given by r equals f of a. So what we want to do is we're going to use synthetic division first, okay, to divide this polynomial by x minus 1. So I'm going to put my factor of +1 up here and then list out my coefficients. So 2, then 0, x to the 4th, -4x cubed, 5x squared, -7x, and 2. So go through this process. So bring the 2 straight down. 1 times 2 is 2. Add, multiply, add, multiply, add, multiply, add, multiply, and add. So we get a remainder of -2. Right? That means that 1 is not a solution to this polynomial. Right? The answer that we end up with here would be, since I started with a 5th degree, this would be 2x to the 4th plus 2x cubed minus 2x squared plus 3x minus 4 minus 2 over x minus 1. Now let's evaluate f of 1. So that means I'm just going to plug 1 in for x everywhere in this polynomial. So f of 1 would just be 2 times 1 to the 5th minus 4 times 1 cubed plus 5 times 1 squared minus 7 times 1 plus 2. So this ends up just being 2 minus 4 plus 5 minus 7 plus 2. right? And I think that'd be negative 2, then plus 5 is 3, minus 7 is negative 4, plus 2 would be negative 2. Wait a minute, that's the same number that we got as the remainder when we did synthetic division. Okay, that's what our remainder theorem is saying. Okay, if a polynomial is divided by x minus a, the remainder is given by r equals f of a. The remainder is whatever number we get when I plug this into polynomial. So if I plug 1 into the polynomial, I get negative 2. That means that negative 2 is the remainder if I were to divide this polynomial by x minus 1. Right? Kind of an interesting fact. So from that, is 1 a root of the polynomial function? Well, no, right? The only way that 1 would be a root is if we got a remainder of 0. Okay, so either thinking about it this way, if I plug 1 in, I would get 0, or if I do synthetic division, I get 0 as my remainder. That's the only way that this would be a root. So we could say no, f of 1 does not equal 0, or we could say our remainder when dividing f of x by x minus 1 was not 0. Okay? So one last idea here. Right? So we can use that remainder theorem to determine if this is a factor of this. So it's not asking me to actually divide. This question is just saying, is this a factor? Well, to do that, I can take negative 3 and plug it into this polynomial. If I get 0, then the answer is yes, it's a factor. If not, no, it's not a factor. Right? We don't have to go through the whole process of division. So let's evaluate f of negative 3. So negative 3 to the 5th plus 3 times negative 3 to the 4th plus negative 3 squared plus 8 times negative 3 plus 15. So go ahead and evaluate that real quick. When we plug all this into a calculator, I think we end up with 0. Right? That means that x plus 3 is a factor. Right? X plus 3 is a factor of this. Now, if I wanted to figure out what would be left over when I divided this polynomial by x plus 3, I would have to go through the process of dividing. And I could use synthetic division. But if I just want to know, is x plus 3 a factor? The answer is yes. All right? So part B then, okay, says we'll use that idea to go a little bit further. So it says show that 2 is a 0 of this function, and then use that information to find all the zeros. So let's take a look at what that means. So first, let's use division, synthetic division, to show that 2 is a 0 here. So write down my coefficients, and let's divide. So bring my 3 straight down. 2 times 3 is 6. Add, multiply, add, multiply. Forgot my negative sign there. Multiply, so we get negative 6, and then we get a 0 remainder. So, since we get a 0 remainder, that means 2 is a 0 of this function. So what we're left with, since I started with a cubic, this would be 3x squared plus 8x minus 3. Well, now it says use the depressed polynomial. That's what this is. Okay, this is a depressed polynomial. Okay, to solve for all values of where f of x equals 0. Well, we found one, right? We found that one of the zeros of my original polynomial is 2. Well, now I just have a quadratic that I can solve. So I just want to set this equal to 0 and solve the quadratic. So we could try factoring, quadratic formula, completing the square, right? Lots of options to solve a quadratic. I think this one will factor. So I want two numbers that multiply to -9 that add to 8. Well, I think that would be 9 and 1 if I make the 1 negative, right? So I have to do factor by grouping here since my leading coefficient is not 1. So this will become 3x squared plus 9x minus 1x minus 3. So I can take a 3x out of here. I'm left with x plus 3. Then I can take a -1 out of these, and I'd be left with x plus 3. So my final factored form of this quadratic would be x plus 3 times 3x minus 1. So now if I solve each of these, setting them equal to 0, that would get me x equals -3. And then here, I'll go ahead and write this out. 3x minus 1 equals 0. Add the 1 over and divide by 3, we would get x equals 1/3. So my three answers then would be x equals 2, our first 0 that we found, x equals -3, and x equals 1/3. All right, so this is where division becomes most useful, okay? Solving something like this, okay? We're going to take a look at this a lot more in the next section, okay? But this is our first intro to using synthetic division to find zeros of polynomials, okay? So we want to divide until we get a quadratic, and then we have a bunch of strategies to find quadratics, all right? So I'll post the homework on Schoology. You can get started on that if you would like, but we will work on that in class on Monday.